Okay, so this is the Kirchoff's law question from the test. You can see that currents have already been given at I1, I2 and I3. So it's quite easy for us to start off by writing Kirchoff's current law for this junction here, where I1 plus I2 must equal I3. The current incoming to a junction equals the current leaving the junction. After that, we can look at any individual loop. So I'm going to start by looking from here around that way. So the EMF as we go through this cell is 12 volts, and that's equal to the potential difference lost. We have to use Ohm's law, V equals IR, to say that, well, the voltage across this resistor is 4 ohms times I3 plus the voltage lost against this resistor, which is 1 I1. That's on the same part as I1. The second loop that I'm going to do is from here around. So the EMF of this cell is 4 volts, and that's equal to I3 times 4, so 4I3 again, plus 2 lots of I2. Okay, we've now got 3 equations and 3 unknowns, so we can solve this via simultaneous equations. The first step is to use your equation number 1. It's always important to label these. Use your first equation and sub it in to one of these two. There's no point in subbing in for I3 because that's already common to both of these equations. So I'm going to rearrange it and sub it in here for I1. So I1 is equal to I3 minus I2. So let's put that in. 12 volts equals 4I3 plus I3 minus I2. Okay, so that becomes 12 volts equals 5I3 minus I2. I'm going to call that equation number 4. We've now got 2 equations that have got I3 and I2 in them. This one, number 3, and this one, number 4. So it's important to now get the same number of one of these terms. So I'm going to double up equation number 4 to get 2I2 in both equations. So I'm going to write a little commentary. I'm going to do equation number 4 times 2, which gives 24 volts, is 10I3 minus 2I2. Call that number 5. I can now either add or subtract my equations. In this case, because one's a positive and one's a negative, I just add them together. So I'm going to do 5 plus 3 gives me 4 plus 24, 28 volts is equal to 14I3, and then the plus 2I2 and the minus I2 cancel out. That leaves me with I3 is equal to 2. We can convert that to amps at this stage. Okay. The last thing we need to do is then use this to find out what I2 and I1 are. So this equation here has only got I3 and I2, so 5 lots of 2 gives me 10. If I move that across to the other side, that means that I've got 2 equals minus I2, and therefore I2 equals minus 2. And the final step, I can use this equation up at the top. I1 plus I2 equals I3. So I1 therefore is I3, 2 amps, minus I2. So minus minus gives me 4 amps. I've now solved it for I1, I2 and I3.